Now that you've completed gathering and analyzing your data, you need to figure out what your data means. This can seem like a big undertaking, but this is where the scientific method can guide us. At the beginning of your project, you stated a research question and developed a hypothesis based on what you've read about previous research. Your conclusions should use your data to answer that question and accept or reject your hypothesis. When you developed your experimental design, you focused on an experimental design that would specifically lead to an answer to your question or the evidence needed to support or reject your hypothesis. While your data may not be as clear as you may have hoped, if you followed strong experimental design, you will have all you need to develop conclusions based on your work. Since you use replicates, you will want to figure out how consistent your results are. To do this, you can calculate a mean and standard deviation for the replicates. If the standard deviation is large, it suggests that your experiment have variable results, while a small standard deviation suggests consistent results. If your standard deviation is large, you will want to think about how you conducted your experiment, if there was variation between your replicates, or if anything didn't go according to plan. This can include measurement error or errors in conducting the experiment. These errors will guide you toward recommendations for how to do this study better next time. With a large standard deviation, the best thing to do is to repeat your experiment to try to reduce variability. If you cannot do that, you can use the mean and standard deviation or the maximum, minimum, and mean values to interpret your data. If your standard deviation is small, you could proceed with data analysis using the mean value, but you'll want to still report the standard deviation. You may be looking at differences between treatments or groups, in which case you may want to use a statistical test to determine if the differences you measured as you change your dependent variable are significant. The most common test to use in this situation is a t-test, which determines the probability that two groups of measurements are statistically similar or different. Other common statistical tests you may use to determine significance of your data include an ANOVA or the chi-square test that is often used in behavioral sciences. Once you have determined how variable your replicates are within each experimental group and determined if your experimental groups are different, either by observation for younger grade levels or through statistical tests for older grade levels, you can then state how changing your dependent variable or variables affected your independent variable or variables. This statement of impact of your experiment may sound like watering soybeans with a low pH vinegar solution led to slower germination than watering with a neutral pH tap water solution or a basic pH baking soda solution. This statement will be the basis upon which you accept or reject your hypothesis or answer your research question. Your conclusion should state how your dependent variables affected your independent variables and should state whether that supported or rejected your hypothesis. In the previous example, we can say that pH does impact germination of soybeans and partially accept the hypothesis that neutral pH water will lead to quicker germination than acidic or basic pH water. In any experiment, there will be unanswered questions, new questions that arise, or things you would do differently. It's considered standard practice in science to state these things at the end of your project. What new questions or ideas came up during your work? How would you change things next time? This could set you or someone else up for further research in the future.